Hello, my name is Isaac Johnson and this is Braden Marin. Today we'll be discussing our team's engineering analysis for NASA regarding the use of O-rings for rocket boosters. The question that we will be working through is whether our launch should proceed when the expected temperature outside is 60 degrees Fahrenheit and O-rings lose sealing capacity around 55 degrees Fahrenheit.
So the O-rings are designed to seal critical joints in the solid rocket boosters, so that is a very important job to have. And at lower temperatures, the rubber material becomes less flexible and more rigid, and so it's slower to form a proper seal. And even though the forecast does predict 60 degrees at launch time, early morning conditions such as wind chill, shading, the metal's heat retention could cause the actual O-ring temperature to drop below that safety limit, which means the system could fail even though it looks like the air temperature is acceptable.
Yeah. And when analyzing our temperature effects on the O-ring performance, historical data shows that failure increases sharply as the O-ring temperatures rise or drop below 55 degrees. Thermal and uneven heating of the rocket components make the true O-ring temperature uncertain. Given this narrow margin, only 5 degrees, any variation could lead to seal deformation or gas leakings, which could potentially result in catastrophic failure. From an engineering safety perspective, this margin is simply too low.
So in forming our recommendation, we considered several constraints. First, there are the schedule and cost pressures associated with delaying a launch such as this one. And however, the requirement for the full seal is very much present in this situation. That must take priority over any sort of cost delays. So we assume that the O-ring temperature will always lag behind ambient air temperature, and a 5-degree safety margin is not sufficient to guarantee reliable performance. So based on these assumptions, the current conditions do not meet safe launch criteria.
And we also looked at the economic side of things. Delaying the launch, even by a few days, could cost NASA millions of dollars, such as in 2005 when they delayed the launch, which cost them $4 million. However, on the other side, the loss of equipment, mission, and human life could exceed that cost greatly. Currently, the cost to build a full rocket is about $23.8 billion. So when comparing that to delaying a launch, the choice is very clear. We should delay the launch and save the money, and also worry about human lives.
So especially from a Christian worldview perspective, our duty as engineers is to value and protect that human life above all else. So pushing forward with a known safety concern would violate that principle, and especially that principle being one of stewardship, responsibility, and moral integrity. So choosing to delay the launch for however long and spending what money it does require in the short term reflects more our ethical obligation to care for the people involved and the mission as a whole, even if it does mean that financial sacrifice.
In conclusion, our team does not recommend proceeding under the current temperature conditions. We advise waiting until the O-ring temperatures are more certain and are safely above 55 degrees with a much more adequate safety margin, such as this. And this agrees with our sound engineering, fiscal responsibility, and moral integrity.
So especially as engineers, our ultimate responsibility is not just to meet a deadline, but it's to ensure the safety and the reliability of not only this mission, but every mission. So thank you for listening, and we'll now open the floor.